The vertex form of a quadratic function is all those parts together. So I have the a value, I have that k value, remember that's my vertical translation, and I have my h value, that's my horizontal translation. The axis of symmetry of a quadratic function in this form is the vertical line x is equal to h. To graph this, we first need to identify the vertex. So it's called vertex form because it's very easy to find the vertex from it. After that, you're going to consider the sign of a to determine whether it opens upward or downward. Remember, upward looks like this, downward looks like this. If a is positive, the graph opens upward. If a is negative, the graph is going to open downward. Then generate 2 points on each side of the vertex. Using those points to sketch the graph. Alright, that's a lot of words. Let's put it into practice. Example 3 here. Here we have this function. Step number 1, figure out your vertex. Your vertex is going to be the point hk. Okay, I got a lot of stuff going on here. Your vertex is hk. So I look at this function. It's supposed to be a times x minus h squared plus k. Well, my h, it looks like it's 1, but it's actually -1 because I have x minus h. So x minus -1 is going to be x plus 1. K is -2. Then my vertex is just -1, -2. So that's my vertex, and actually it says it right here. Then we make a table for the function, find 2 points on each side of the vertex. So they just took the equation and just outright plugged in the x values to get your y values, and they got those points and they graphed it here. Okay, so you can look at that example. Part B here, 2 times x minus 1 squared minus 7. Step number 1, identify the vertex. So a times x minus h squared plus k. Okay, first of all, my h value is right here. My h value is 1. Is it 1 or -1? Well, x minus h, so h is actually 1 this time. Now my k value, -7 plus k, so k has to be -7. 1, -7 is my vertex. Let me graph that. 1, oh, it's going to be low. 1, -7. Alright. Let's look at our a value. My a value is 2. A is 2. So my a value, since this is a positive number, that's going to tell me my graph is going to open upward like this. So when I do my points, I should expect it to look like that. Also, the absolute value of a is greater than 1, meaning that it's going to be a vertical stretch, so it might look kind of narrow, a little bit more like that. Alright, so you can plug in your x values to get your y values. I already know 1, -7 is my vertex. I know that's going to be on there. 0, so let's see. So 2 times x minus 1 squared minus 7. If I plug in 0 for x, 0 for x, I'm going to get -1 squared, so 2 times 1. So 2 minus 7, -5. I get -5 there. And I realize you can actually just put this into a calculator. That'll probably make your life a bit easier. Let me just do it in my head real quick. 4 minus 1, so 3, 9, 18, 11. Okay, and that's probably 11 too. Okay, that looks right to me. So here's my points, 2, -5. And 0, -5, and then 4, 11. Let's see, oh, that's pretty high up. -2, 11. Okay. If you catch a mistake in any of my videos, just let me know. I'll give you like a piece of candy or something. And here's my parabola. There we go. So we just transformed the parabola. Again, we said it should open upwards because our a is greater than 2, and it is opening upwards. Okay. And we said it should look kind of narrow because our a value is, absolute value of a is greater than 1, and it does look kind of narrow, so that's good. We have actually Our vertex, again, 1, negative 7. We got that from our h and our k. 1, negative 7 is our vertex. That means also the graph is shifted to the right 1. Okay, because x minus 1, just like earlier, that's going to shift it to the right by the h amount. So everything is shifted over by 1 from the parent function. And then our k value is negative 7, then everything is shifted down 7 as well. So like on the parent function, this point 0, 0 goes down there. The point 1, 1 on the parent function goes right 1, goes down. If it went down 7, it would go here. But since it's going to be stretched, it's going to be a little bit different. So you just focus on the vertex first and translate that. Okay. But when in doubt, just plug in a bunch of points and graph it that way. Okay. Alright, that's the end of the lesson. So just to recap, I know there's a lot going on here. Maybe it helps if we go back to the very first example. Our first step, actually, what they did here was they graphed the parent function, right, x squared. Then they stretched the y values times everything times 2, or sorry, just the y values times 2. Alright, here they had x minus 3 squared plus 1. So my h value, it's not going to be negative 3, but it's going to be 3. My k value is going to be 1. That means I should expect my vertex to be at the point 3, 1, h and k. And was that right when we graphed that? 3, 1 is indeed our vertex. Alright. And then everything else is shifted over 3, up 1. Over 3, up 1. But you had to actually stretch the graph first. Alright, so I know it's a lot. You got the vertical stretch / compression component, and then you have the translation to the right or left and up or down. On your star sheet, you actually have this vertex form written out, but we will do more practice over this to make sure we know how to use this. So again, vertex form, vertex is hk. Just be careful with a negative sign there. Your h, you might miss a sign if you are not careful with that. Okay, if you missed anything, just pause the video or go back to the first part and review any of that to make sure you understand what's happening here. Make sure to do your homework to really understand everything. Have a good one, and think win-win.